destinated the crude oil and collected the naphtha, kero and diesel. So before going through these cuts by qualitative analysis, then there is no use of these cuts. So you must have to go through the qualitative assessment. So the very first property of to assess the quality of the naphtha, that is ASTM D86.
D86.
Got my point? It is not working. Right. So this is the ASTM D86. By this D86, here you can come to know what exactly is the thing in C5 to 140 degrees centigrade. Whether this C5 140 degrees centigrade is rich in benzene or rich in toluene or rich in xylene, or whether this has got some part, maximum part which we can use in a gasoline pool. Got my point?
Yes.
So by this, what we are doing, we are taking 100 ml of the sample in a distillation flask, which is already in the caps over here. But right now we don't have a naphtha, we have a diesel cut, and you can see we have a two chamber, one for HSD, high speed diesel, second for MS, motor spirit, for gasoline. Why it is so? Actually, when you will see, the intensity of the heater is quite high of this HSD from the heater of the MS as compared like. Now here, while you are doing the D86, somebody can ask you, can you give the one qualitative assessment property of the naphtha? How we can or what is the name of distillation which can assess the quality of the naphtha? So that is your D86. Okay, and in D86 there are four groups: group 1, group 2, group 3 and group 4. Sometimes it has been asked, what do you mean by these groups? These are the four groups called ASTM D86. Here in group 1, here the base of the surface plate which we are using for the D86, that will be 35 mm. 35 mm in group 2 as well. But in group 3, it is 38 mm, and group 4, it will be 50 mm. Got my point? This is the plate surface. I will show you through which your heating is passing. So I will show you. This is the surface plate. You cannot use this surface plate while you are distilling the naphtha or gasoline. Oh, sorry, diesel. This is for naphtha and gasoline, where the surface diameter of this plate is 38 mm. Okay, and if you have a spirit or light naphtha or benzene, for that you require a plate which has got this surface dia 35 mm. Now question is arising, what will happen if we are using the plate which has got the dia rather than 35, it may be 50 mm. So what will happen then? See, actually when the boiling point is high, for that you need a high intensity, or you can say the more surface area, or you can say that the maximum exposure of the heat, so that high boiling point compound can boil. But if you will use high diameter surface plate for the hydrocarbon which has got the lower hydrocarbon, it may flood. You cannot get the product in the segregation form. That is the main thing. Second thing, the data which you will collect by wrong plate, that is not correct. Okay. So right now what I am doing, I have a diesel, commercial diesel, diesel ही है नहीं, है ना? I have a diesel. For diesel, I am using the plate which has got the diameter 50 mm. And okay, 100 ml of the sample, and this is my receiver, and this is the condenser. Now it is very important for both the cases. While you are doing the diesel by D86, or you are going to check the quality of the diesel by D86, your condenser should be at 55 to 60 degree centigrade. Because as I told you, from 270 or 275 there will be a paraffin appearance. If you are not hitting the condenser after 270, this capillary will choked from the inside to this side. Your sample is passing through the but not reaching into the condenser, because due to time your condenser will be at 0 to 4 degrees centigrade. Similarly, the condenser where you are getting the distillate, that condenser will be also at 0 to 4 degree. But in diesel cases, when you are doing the distillation of diesel, so no need of this condenser should cap in at the 55 to 60 degrees centigrade. It is not required. But for gasoline, it has to be kept, both the things, condenser as well as the receiver should be in same temperature. That temperature will be 0 to 4 degrees centigrade. Here what we will check? We will check the initial boiling point, then recovery of the volume at 5% temperature, 10% temperature, 20% temperature, then 30, 40, 50, 60, 70, 80, 90, then 95. After that, FBP, final boiling point, then recovery, then residue, then loss. Now, because I am doing diesel, definitely I will talk about the diesel. While you are doing the diesel, you will check the IBP. Generally, the initial boiling point of the commercial diesel, it comes near about 125 to near about 145. It may be sometime higher than this, but generally it is 125, 130, sometime 138. It depends upon the condition of the diesel. But it should not be less than this. If your IBP is less than 125, so though there is no specification of IBP in diesel cases, but this will be failed where maybe it will fail in density. It may not fail in density, but definitely it will fail at flash point. Because I have my one paper published which is relation between D86 and flash point. So if your IBP is 125, definitely the flash point of that particular diesel hydrocarbon is either 35 or 25. If it is exactly 35, so minimum flash point for the diesel by Able, there are three type of method: Able, COC and PMCC. But the commercial diesel flash point will be either minimum 35. So if it is minimum 35, this is the boundary condition. If something happen, it may reach 34 degrees, your sample will fail. So that is why IBP is important. Got my point? Second, IBP is the indication of flash point. Exactly. From this IBP, you can understand. You can come to know if IBP is this much, my sample may be failed.
So is it proportional or inversely proportional?
Not directly. This is just my experience. There is a relation, and there is also my paper. There is a relation between. You only give me the D86 data. I can tell you by calculation what will be the flash point of the particular sample. Okay. Now, up 5% recovery. 5% volume at what temperature it is coming, that you will have to check it out. And the most important thing here, you need T10, T50, T90 for what? And you need density. These data you need for your what you need, viscosity index, not C10 index. Because if you are a researcher person, if you are doing the C10 number, for C10 number at least you require 1.5 liter of the sample, if you are doing by the CFR engine. But if I am doing research, I have only 10 or 20 ml of the sample. How I come to know what is C10 number? So I can go for the C10 index. C10 index is just like a C10 number, but C10 index is 6 to 10 lesser than the C10 number, because C10 number is adject, which we are doing by the engine, and this is by the calculation. To calculating the C10 index, we require density and T10, T50 and T90 data. Sometime when you will see in ASTM D86, which is manual, that automatic unit will calculate itself the C10 index. Okay, so that is also required. Now, other thing which is very, very important, the recovery at 360 degrees centigrade. Recovery of the diesel at 360 degrees centigrade, minimum 95 will be there. Minimum 95%. You can sit. Yeah, right. If somebody feel problem, you can sit easily. 360 degrees centigrade, you require minimum 95% recovery. Now again question, if 95% is not there, definitely your sample is failed. It is failed. Okay, and residue should not be more than 2%.
Residue or
Loss always 1, not more than 1.
Residue
remaining. But it should not have the residue more than 2%. If residue is more than 2%, now think, while you are taking 100 ml of sample, you are lefting with the 2% of the residue. Now you are using your diesel vehicle where you are putting 40 liter of the diesel, and 40 multiplied by 2%, that much amount is depositing in your tank. Gradually that will react with the diesel, and that diesel is passing through in your engine, and gradually your engine is going to be damaged. And then you will just blame the company who make that particular vehicle and tell them, what are you doing, and this is not good.
Knocking. Refinery personnel try to produce the required quantity of fuel as per engine design, or the engine designer design the engine as per fuel quality. Which one?
Actually, whatever we have the engine right now, it has been designed according to the diesel. According to the diesel which we have. And the diesel finalized so that the residue should not be more than 2%. Yes, no. First we will check the temperature.
What smoke is coming out?
It is vapor.
For hitting the cooler?
Condensate.
There is a simple water is there. Simple. It is 45 right now. 55 to 60. It has to be 55 to 60.
This is condensate,
This is not a condensate. This condenser. This is condenser. Exactly. Actually, you are mixing condensate and condenser all together. Condensate and condenser.
Condenser and condensate.
Do you understand what is condensate?
Condenser for cooling. Condenser.
No. Condensate.
Condensate.
You are working on, you know. What is condensate?
They're coming out from.
No. This is condenser.
Hydrocarbon.
I am talking about condensate.
Condensate.
Condensate. Condensate.
Condensate the product of
Yeah,
after
right.
condensing. Yeah.
Right. Actually, from where this condensate is coming.
Yes.
Product after.
Actually, when you are drilling to digging out the crude oil, and you know there is a very high pressure. So when you are digging the crude oil, at that point of time, the vapor which are not converted into the liquid, that is escaping from the earth, and when obviously this is the part of hydrocarbon, that has to be connected into a reservoir where is an environment is very cool. So that will escape from the ground in the form of vapors. Then after reaching in the condenser, where condenser will be at very low temperature, when that will reach over there, that will convert into the liquid. That liquid is known as condensate. And the range of the condensate may can go up to C16. Starting from C1 can go up to C16, because we have done so many condensate distillation and it is reaching from C16, C15, C14, because due to high pressure, heavier molecule also is converting into the vapor and reaching to that condensate chamber.
We even find the condensate from the gas.
Obviously, yes.
The heaviest part.
Yes, true,
Yeah,
yes.
Drop.
All these things is underground where pressure is high. When you are drilling, definitely it will escape off.
So sometimes we call the condensate the condi. What I call condi?
Condi.
Yeah, condi and condensate. What is the difference?
There is no difference. Condi or condensate is same.
The same, condi.
Right.
Sometimes we call condi.
This short name, like Edward, Andy.
Yeah.
My name is Sundaram. Everybody try to use Sundu. This short name. Condensate is Kandi.
Yeah, condi. The same.
Right, right.
Like Thomas Tom.
Saving time.
Now Thomas is Kondi.
Tom.
Tom is
Tom.
Kondi.
Why?
Thomas. Short name for Thomas.
Tomai. Tomai.
You know Thomas?
AK Kondi.
Why? Different.
It's a good name.
Here the commercial diesel you will see.
Okay.
When we start D86, here you will find the temperature interval when you are collecting the 5% and 10%, 10 to 15 degrees centigrade. While you are doing the biodiesel sample, you can get, suppose if you are getting the biodiesel 5% recovery at 100 degree, for example, if biodiesel, if you are getting 5% at 150 degrees centigrade, you never know that your 10% recovery will come at 151. This is the difference basically with the commercial diesel and biodiesel. Only in 1 degree you are getting 5%. That is the main reason, because this biodiesel is not that much stable. Or its IBP is starting from 250 and whole the biodiesel is finishing at 350. Then what is the use of this?
Or even below.
Even below. And we are talking about alternative fuel. This type of alternative fuel.
Mixed fuel.
So biodiesel will not be never alternative fuel.
Okay.
Never.
Though you can mix
It's
5%, 10%, 20%, up to 20% you can add on, no problem.
Okay.
But 100% never. For that you will have to change the engine.
Yes.
And to change the engine is a tough task. Who will change the engine?
Change the engine for what?
To use
If you want to run the biodiesel.
Time and necessity will change the engine. Why?
Yeah, in future. Maybe we all are not present
Till that time.
Till that time.
Which part if we
What part will you have to change?
Which part? Each engine.
Efficiency, It works
As
but
I told
efficient.
you, in 1 degree you are getting 5 to 10%, but when you are doing the commercial diesel, this is from hydrocarbon, you can get, suppose if 5% you are getting 150, so definitely 10% you will get at 165. Sure, in diesel case. But here is the case. So you will have to prepare such type of engine
That's God is
in
great.
which you can use the biodiesel. Now think,
This means that the things from God are very powerful.
yeah.
Oil coming from God.
Yeah, the natural process.
NDAT.
Yeah, I mean,
I have a
biodiesel is the
paper
human being
which
made,
has been
but
published
that's crude
by
oil
me,
that's
Dr.
from
Rajesh
natural.
Sharma ji and Dr.
Process.
Yama ji and V.S.
Human being can only put the seed, huh?
Yeah, sure, definitely.
What is that?
I will give you.
Then,
Uric acid.
Hmm?
Uric acid.
Right. Somebody.
that's imagine.
Want to understand what we are saying. So what we are saying is that we are going to use 100% biodiesel, sir.
Someone condensate. Hapa ni maji, hapa ni maji, nothing.
Can I show you one of the test reports of the where we're covered?
So no,